of thing. Okay, this is the 1-3 experimental design and chapter 4 designing studies notes. This is pretty long, so I broke it up into 3 sections, and I will have 3 different videos. So this is video 1. In this video, we're going to talk mostly about sampling and surveys. This is covering AP topics 2A, B, C, and D. And we are pulling from 2 different textbooks with all of this information. So what you should learn is you should learn to identify the population and sample in a statistical study, identify voluntary response samples and convenience samples, explain how these sampling methods can lead to bias, describe how to obtain a random sample using slips of paper technology or a table of random digits, distinguish a simple random sample from a stratified sample, random sample, or a cluster sample, give the advantages and disadvantages of each sampling method, and explain how undercoverage, non-response, and question wording and other aspects of a sample survey can lead to bias. So the AP topics that are actually being covered with this is from the sampling, experimentation, planning, and conducting a survey. There are about 10 to 15% of the questions in the AP test that's covering that. We're going to specifically look at census and sample surveys. We're going to look at the characteristics, the populations of samples, the bias, and methods. So throughout the year, we're going to be organizing our answers using a 4-step process. We're going to state what the question that you're trying to answer. We're going to plan how will you go about answering the question, what statistical techniques might be needed for the problem to find a solution. We're going to make graphs and carry out needed calculations when appropriate. And we're going to come to a conclusion. Give your conclusion in a setting that relates to the real world problem that the question was started with. So to keep the 4 steps straight, just remember statistic problems demand consistency. It's a mnemonic to remember. So the first type of data collection that we're going to look at is a survey. It's an investigation of one or more characteristics of a population. Some examples are conducting a census or a poll using sampling of the population. These are the other data collections that we'll be looking at in other sections of these notes: experiment, simulation, and observational study. Also, I wanted to note that there is a star on this slide, which means that what's on this slide is important for note taking. So anything that's any starred slide, make sure you copy those notes. So how to sample badly? Let's start with the worst, and we'll go to the correct way of doing it. So a convenience sample occurs when the sample involves choosing individuals from the population who are easy to reach. So an example is surveying individuals entering Walgreens about medicine choices. Walgreens, pretty much, that's what they do, medicine, so that's why it works. The design of a statistical study shows bias if it would consistently underestimate or consistently overestimate the value you want to know. A volunteer response sample consists of people who choose themselves to respond to a general invitation. So a convenience sampling often produces unrepresentative data. An example would be if you were wanting to find out how much time a student at Temple High School got to sleep the previous night, you might conveniently ask everybody that's walking in the front door. The problem with that is everybody that walks in the back door is not being represented. So people that ride the bus, not represented. People that ride cars is represented. So it's not representing the entire population. Bias is not just bad luck in one sample. It is the result of a bad study design that will consistently miss the truth about the population in the same way. Voluntary response samples are also known as self-selected samples. Here's an example of a problem that would relate to this. And I've done this for several ones. I'm not going to read through this whole thing. You can go back and relook at this if you are trying to get an idea of how to word an answer. That's the whole purpose of all of these examples that I'll be giving. So you have a situation where you have an article. You have the question, what type of sample did the Times use in this poll? Explain how this sampling method could lead to bias in the poll results. So the solution, you would want to be very detailed. So that is really important. It's not going to be a one sentence answer. Remember that these type of problems that are on here are all representative of the test questions that you might see in especially the free answer portion. So it's really important that you pay attention to the types. So here is a check your own understanding. Here you on Edpuzzle, you're actually going to answer these in a you're going to come up with the answers, and then you will see the answer that should be there. So a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 of the oranges from the top of each crate before deciding whether to buy all the oranges. So for each of these situations that you'll see, identify the sampling method used and then explain how the sampling method could lead to bias. So the solution you should have come up with is it is a convenience sampling, and this could lead the inspector to overestimate the quality of the oranges if the farmer puts the best oranges on top. It's kind of cheating, but it does happen. So just that, this is the type of answer you should be seeing on your assignments when you're turning in the assignments. This is what I'm looking for. So a second question, you have an ABC Nightline once asked whether the United Nations should continue to have its headquarters in the US. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded and 67% said no. So which sampling method is used and how can it be biased? The answer is voluntary response sampling. And I'll let you read the rest. So how to sample well. Simple random sampling is the best way to sample. Random sampling involves using a chance process to determine which members of the population are included in the sample. A simple random sample, SRS for short, of size, say N, is chosen in such a way that every group of N individuals in the population has an equal chance to be selected as a sample. So for instance, you have 100 people, you select 10 people. So you could group them, randomly grab 10 different people and keep grouping 10 people in different groups. A simple random sample says that no matter which group you chose, everybody in that group and everybody in the population had an equal chance of being in a group that could have been used for your sample. So in everyday life, some people use the word random to mean haphazard, as in that's so random. In statistics, random means due to chance. Don't say that a sample was chosen at random if a chance process wasn't used to select the individuals. That's very important. So choosing an SRS with technology. There's a couple of ways that we can do this. With technology, first and foremost, always label your population. So say your population was 100 people, you would label them 1 to 100. And then you would randomize. You would use a random generator to obtain the number of people in your sample, the sample size, that many integers between 1 to n, and whoever those integers belong to, that's who's in your sample. So using a TI-84, you would use push math, PRB, and ran int 1 comma, and then however big your size of your 1 to whatever your number of people in your population. Same thing basically with Inspire, it's just a different menu option. So something to remember, there are certain errors that might pop up, and these are things that have been seen quite often with the AP exam. So anytime that happens, you will see this alert. When describing how to select a sample using a random integer generator, remember to address what to do with the repeated integers. So say you hit enter on your calculator and you got 13, 13, 12, 7, whatever. If you have repeated integers should be eliminated. So you need to say that when you're writing out your explanation. You should explicitly state that repeated integers should be ignored, or say that you will generate random integers until you get n different numbers in a specific range. Two different ways to say it, same information. Make sure you say that, because that will lose you points if you do not. So here's an example of a problem that you would do this with. The local genealogical society in Coles County, Illinois has compiled a records on 55,914 gravestones, and we want to choose an SRS of 395. Obviously, going randomly, a calculator is going to be the quickest way of doing this. However, you could use another option called a table D, which we haven't talked about. So they want you to describe how you would use your calculator, make it clear enough so that if someone else was to sit down and read your instructions, they could do it themselves, and then tell what your top three gravestones, the top three numbers of gravestones would be. So using a calculator, you would number the gravestones 1 to 55,914. Then you would use the command randint. Notice how it's spelling out exactly what you should be doing in your calculator and on paper. To select 395 different integers from 1 to 55,914. And then using the corresponding 395 plots. So you're going to do 395 plots, hit the enter basically 395 times, possibly more than that if they repeat. Your answers may vary from your neighbors because the calculator is randomly picking integers. So sometimes they match, sometimes they don't. But either way, it's a random. The answers must not repeat, and they must be in the range of 1 to 55,914. Okay, so the second way we can create an SRS is using a table D. A table D is a document there is a link in Schoology that takes you to a spreadsheet. And again, the same basic setup is what you would do. You would label every one of your individuals in the population. This time, however, you want to label them as 0, 1 to 50. 2 digits if your biggest or your size of your population is 2 digits. 3 digits if it's 3 digits. Everything has to have the same number of digits. So 0, 1 for 1, 50 for 50, or 001 for 1, and 100 for 100. Then you would randomize. You would read consecutive groups of digits off of the table D along the same line until you have collected enough distinct labels within the range of your group or your population. So when working with a table of random digits, it is very important that each label have the same number of digits, and you can lose credit for failing to address what you would do with repeated labels. So same idea as the technology alert. Make sure that if you're going to have, you think that there might be a repeated label, just state repeated labels will be, or repeated digits will be eliminated. So let's look at an example. So you have mall hours, you have 21 different mall stores, and you want 3 of them to be chosen at random. So first you would label all the stores 01 to 21, like I've done on this side. And then you would use a specific line on your table D, line 101, and just keep reading across until you found the 3 distinct numbers that are between 01 and 21. So I've listed out what your line 101 would look like. The first 2 digits is 19, so Star Jewelers gets picked. The next 2 lines, 22, well, that is outside of our list. 22 is not one of our lists. We skip it. 39, 50, 34, all skipped. And then 05 is the next 2 numbers, which are Carter's for kids. 75 skip, 62 skip, 87 skip, and then 13 Mrs. Fields. So our 3 choices would be Star Jewelers, Carter's for kids, and Mrs. Fields. Okay, so other random sampling methods. To get a stratified random sample, start by classifying the population into groups of similar individuals called a strata. Then choose a separate SRS for each stratum and combine these SRSs to form the sample. So stratum random sample example would be group by age or sex, then choose a random sample from each of those groups and then combine them together to make your population sample. To get a cluster sample, start by classifying the population into groups of individuals that are located near each other, such as called clusters. Then choose the SRS from the clusters, and all the individuals in the chosen clusters are included in the sample. So an example of that would be randomly choosing residents from each city in Texas by city, then include them in the overall sample. And then a systematic random sampling occurs when you start by randomly choosing one individual from the first portion of the population, then every specific set number of the population thereafter. So an example would be when examining 100 iPhones produced at a factory on a given day, you randomly choose a phone from the first 50 produced, and then every fifth phone thereafter to determine the sample set. Note, this is not an SRS. It is not random sampling, and it actually does create bias. So here's another check your understanding. So you're looking to see is what is the name for the kind of sampling method described, and give a reason why the lumber company chose this method. And the answer is it is a cluster sampling, and it's to save time and money. In an SRS, this company would have to inspect trees all over the entire forest instead of only the 20 locations. So inference for sampling. The process of drawing conclusions about a population on the basis of sample data is called inference, because we infer information about the population from what we know about the sample. The first reason to rely on random sampling is to avoid bias in choosing a sample. The second reason is to use random sampling is that the laws of probability allow trustworthy inference about the population. Results from the random samples come with a margin of error that sets bounds on the size of the likely error. Larger random samples give better information about the population than smaller samples. So what could go wrong? Well, you can have undercoverage, which occurs when some members of the population cannot be chosen in a sample. You can have non-response, which occurs when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of inaccurate answers in a survey leads to response bias, and the wording of questions is the most important influence on the answers given to the sample survey. To illustrate how undercoverage could lead to bias, imagine that what would happen if you did a survey about increasing funding for Medicare by calling random selected landlines. Because many younger people only use cell phones, this method will likely overrepresent older people. Our estimate of the portion of people who favor more funding will likely be too high. When discussing any type of bias, speculate on the direction of the bias. For example, if a survey about unemployment was conducted over the phone, non-response will lead to bias. It is likely that the estimated proportion of unemployed will be too high because people who are unemployed are more likely to be at home and available for the survey. Don't trust the results of a sample survey until you have read the exact questions asked. Some students misuse the term voluntary response to explain why certain individuals don't respond in a sample survey. What students are describing is non-response. Think about it this way. Non-response can occur only after a sample has been selected. In a voluntary response sample, every individual has opted to take part, so there won't be any non-response. So an area you can lose credit in is when you're describing what can go wrong in sample surveys because you use incorrect terminology. To be safe, Clearly describe the problem and its consequences in the context of the question, rather than worrying about naming a specific problem or source of bias. So an example is, how do Americans feel about illegal immigrants? So these are question worded where question wording matters. So each of the following is a possible source of bias in the sample survey. Name the type of bias that could result. The sample is chosen at random from a telephone directory. Some people cannot be contacted in 5 calls, and interviewers choose people walking by on a sidewalk to interview. So the first one is under coverage. The second one's non-response. And the third one is under coverage. Excuse me. Explain how the wording of the question can result in bias. Be sure to specify the direction of the bias. By making it sound as if there are not a problem in the landfill, this question will result in fewer people suggesting that they should ban disposable diapers. The proportion who would say yes to the survey question is likely to be smaller than the proportion who would say yes to a more fairly worded question.